Welcome everyone. In this video, we will talk about tangent plane and linear approximation. So consider this function right here. This is a function of two variables, and note that this is an explicit function. So this is a very important idea, explicit function. That way we can keep that in mind as we compute the tangent plane. So given this function, we want to determine what is the equation of the tangent plane at this point, and then we're going to use our tangent plane, because that's what we're going to call linearization, to approximate this function value. All right, so let's see how we're going to do that. So we know that the equation of a tangent plane of an explicit surface or an explicit function is going to be z minus zo is equal to partial of f respect to x of x minus xo plus partial of f respect to y of y minus yo. And we're going to go ahead and compute what is our zo, meaning the function value at the point t. And then we're going to compute the partial of f respect to x, plug in the point t, and then partial of f respect to y also evaluated at the point t. So let's pick up those pieces and then we plug everything in. Then we have our tangent plane. All right, so I'll compute the partial of f respect to x first. So that is going to be differentiating this function respect to x, holding y as a constant. So differentiate this, that will give you 2x, and then we differentiate this respect to x. So y is a constant, 4 is a constant, so the derivative of that will simply be negative 4y. And the derivative of a constant, of course, we know that's 0. All right, now we're going to evaluate this. So we evaluate our partial of f respect to x at the point 2 comma 5. That is going to be 2 times 2 minus 4 times 5. And this will give you 8 minus 20. And if you simplify this, this will give you negative 16. All right, so that is our partial of f respect to x. We'll substitute that right here. All right, now let's go ahead and continue to the next partial derivative. So we'll now compute partial of f respect to y. Now we're going to treat x as a constant. So this is going to be 0. Differentiate this respect to y. X is a constant, 4 is a constant. So that's simply negative 4x. And then differentiate 2 respect to y. That's also 0. Okay, now we substitute our value. Now we're going to evaluate this at the point 2 comma 5. Plugging in x equals 2, we have negative 4 times 2. That would give us negative 8. All right, so that is the value we're going to substitute right here in our tangent plane. All right, the last thing we need is this number right here, zo. That's the function value at the point t. So I'm going to go ahead and evaluate that. Let's do that on the side. So zo is simply the function value at the point 2 comma 5. So I'm going to plug in my x and y values into the function. That would be 2 squared minus 4 times 2 times 5 plus 2. So I'm simply plugging in the x coordinates and the y coordinate respectively. And if you evaluate this, this will give you about 4 minus, this is 40 plus 2. This is about negative 34. All right, so that is our zo. Now, substituting everything into the tangent plane, we will have our tangent plane to the surface at the point 2 comma 5. It's going to be z minus zo, that's negative 34, is equal to partial of f respect to x, that is negative 16, as we computed x minus xo. Well, xo is again your point right here, that's 2. So it'll be x minus 2. And then plus, but this is a negative partial f of respect to y. That's negative 8 times y minus yo. Yo is 5. That is your tangent plane. Let's clear things up. So I can turn this into a positive value. This is positive 34. Now, if you are happy, this is a good answer. You can leave it here. Or if you move the 34 to the other side, you can also write z is equal to negative 34 minus 16 times x minus 2 minus 8 times y minus 5. You can also leave your equation of the tangent plane in this form. Or if you want to take it further, you can continue to distribute and you get another look to the same plane. All right, so that is our tangent plane. Now we're going to use this to approximation because now we're going to call this L of x comma y. So our function f of x comma y, as long as we're near the point 2 comma 5, will give us a good approximation if we use this tangent plane to approximate. So this will be approximated by L of x comma y. And L of x comma y is simply this plane right here, the tangent plane. So our function, the linearization, is simply negative 34 minus 16 times x minus 2 minus 8 times y minus 5. That is what we call linearization or tangent plane approximation. Now we're going to substitute our value that we're approximating. So now that we're approximating the function value, the function at 2.1 and 4.9. Note that these 2 points are very close to 2 comma 5, so it will be a good approximation by using this tangent plane. So here's the point. I'm going to substitute them. So L of, so we can say that this is going to be approximately whatever L value of 2.1 and 4.9 is, with a small error, of course. This is negative 34 times, sorry, not times, minus 16 times x. Here, I'm going to substitute 2.1 right here and 4.9 right here. So you'll have 2.1 minus 2 minus 8 times 4.9 minus 5. So simply substituting them into each x and y. And then you evaluate this. So this is negative 34 minus 16 times, well, this will give us 0.1 minus 8 times, and this will give us negative 0.1. And then this is simply going to give us 34.8. So that is our approximation to this function value. Alrighty, so that is it for this video. I hope this helps. I'll see you next time. Take care, everyone.